So let's say that you wanted to search my YouTube page for videos, because let's say that I really had trouble with the complex numbers stuff. So I want to look for some complex numbers videos. If you go to servervideo.com, it brings you here. Again, it doesn't say that in the address bar because when you type it in the address bar, servervideo.com, it's a link. No, it's a redirect, and it redirects you to this website, which is part of YouTube. It's my channel on YouTube. All right, so here I am in my channel. Now, yes, there is a little search bar right here, but I have found that it's kind of clunky to use because you have to know exactly what word was in the title, and that's difficult to know. So instead, maybe you should just go back in time. It's like a little time machine. Because the first video here, the top video, it says January 10, Review of Functions chapter. And apparently the title's cut off there. But anyway, and that was from higher algebra. That's what I did on January 10th, which was yesterday. Okay, so if you wanted to obviously look at yesterday's video, that's where you find it. It's at servervideo.com. Some of you maybe have never been here before. But if you want to drag back in time, you can go back and say, well, actually, the one I did, I remember it was in December. December 19, December 18, December 15. If it was right in the middle of December, maybe it's that. Or maybe it's this one right here, HHA Holes in Functions. See what I mean? I can just go back in time all the way to the beginning of our year. The very first video that I recorded would probably have been in September. If you drag all the way to the bottom, then the computer refreshes and gives you more to drag. So there's October, and here's day 1 of school. Will be September, probably 5th or something like that. I'm getting close. Anyway, I think you get my point. Every single video I've ever recorded is sitting here waiting for you. Okay, there's September 8th, HHA, function notation, day 1. So it's a way that you can study for the final and get video help. So it's not just looking at a practice problem on a page. All right? So I wanted to point that out as an option. Now, how about those practice problems that are on a page? Those are over here in Schoology. So hopefully you've already opened your folder up and you're seeing these. You remember that we did this one and this one yesterday, right? So now we're doing complex numbers, final review, and the other one later this hour will be Quadratics A. So would you please open complex numbers, final review, and I'll pause till I get that. Okay, here we are on the complex numbers review. This was chapter 3, the third thing we did, and it's about I. Remember I? What was the one what's the I replacing? Square root of -1. Good. What's even more powerful than I is knowing what I squared is, because that's the one I've seen on the ACT test over and over again. If they throw in a question about complex numbers, it's usually going to be about an I. And then if you know that I squared is -1, it's really, really easy. So if your answer comes out to 6I squared, you just have to know, oh, so that means 6 times -1. You know what I mean? So I squared being -1 is a really big deal in this chapter. All right, so I'm going to assign on this one a bunch of these. They're really quick. You're going to do A, you're going to do C, you're going to do D. These are just, the answer just comes out negative to whatever the square root was. That's a little bit simplistic. Then I want you to do I and J. Now these are right off the top 20. If you've already learned this, the only thing is they have negatives under the square root. So what do you have to throw in your answer? An I. All right, so let's do an A just the right way. You do not have to show all this work. If you understand this, you can just jump right to the answer. It's okay, but I want to show people why. Square root of 4 times the square root of -1 will give me square root of -4. And I break it up that way because this one's 2 and that one's I. That's why the answer is 2I. This is one of the only questions on the whole sheet that I wouldn't need to see any work shown. All right, how about the square root of 18? That this doesn't work out as nice because it's not a perfect square. You can still make it root 9 and root 2. I strongly encourage you not to try to do that step in your head because kids screw it up all the time. You know what I see as the answer? 2 root 3 all the time. You see what I'm saying? That's not the right answer. What is the right answer? 3 root 2. And they get that all mixed up. And yes, there is an I involved because there's a square root of -1. And that's the I part. That's I. That's 3. That's root 2. Try to do it all in your head. You probably end up saying 2 root 3 or something weird like that. 3I root 2 is your final answer on C. All right, this one's different because it's an add question. So once you get this, you're adding it. Don't go and multiply them. Yes? Yep. Yep. Nope. You always just take whichever one works out of the two. So like let's say I had just broken something down into root 9 and root 11. It doesn't matter which one's bigger, it matters which one works. Okay, so root 9 is the only one that works. So then I'd say it's 3 root 11. See what I mean? You always put the whole number in front of the root. Okay, good enough on that. How about we do one together, this I. I is an ignoramus. And I'm going to take the square root of 28 first. I need somebody to help me. What's a good thing to break it into? Root what and root what? Root 4 and root 7. And of course, there's also going to be an I, right? Because there's a square root of a negative there. Now, I did skip a step of making that square root of negative 1, but I think it's okay. And then this is a 2, so then I'm going to say it's 2I root 7. So now I'm going to rewrite it because it's gotten a little messy. Negative 4 plus and minus 2I root 7, and that's all over 8. But I'm going to start factoring right away. The 8 is really 2 times 4. How do I know that I'm going to want a 2 there? Because I can see ahead of time that there's a 2 in both of those. So I'm going to factor that further. Your hand hasn't been touching your iPad in a while, so I need you with me. Not all of you, as somebody that I was talking to. They know who they are. When I wander over there, there better be some work on that iPad. Okay, so this has a 2 in both parts, so I'm going to take out the 2. What's left when I take out the 2? Negative 2 plus and minus. The 2 comes off of this part, and I have I root 7 all over 2 times 4. Now do you see why I took the 2 out? Because it could cancel. And your final answer is right there. I'll leave it there for a minute. I know it's hard to see things that are at the bottom of the board. But if I scroll up, it won't go up the screen because I'm in a PDF. I hope someday they figure out how to fix that. It should be like the smartboard where when I scroll up, it moves up too. All right. So far, I have assigned you A, C, D, I, and J. Okay? We're going to clear that off and move on. In K, L, M, and N, there's a bunch there that have the I squareds in them. Do you think those are important? Of course they are. The I to the third is really an I squared times an I. That's how you break it up. Why did I do that? Because I squared is negative 1. Negative 1 times I makes negative I. I want you to do L and M. And I want you to be really careful with your negatives. I squared's easy. It's negative 1. But just be careful. There's going to be negatives running around all over the place. This has got an I squared. This has got an I squared. This has got an I squared. They're all negative 1s. There's a negative in it. So, all right, so do K, L, and M. I did K for you already. Next, we're going to do problem 2A. And there's 2 ways to do it. If you can factor it, you should. Can I factor it the way it is? No, but you always set these things equal to what first anyway? Equal to 0. Now with this one, just don't even do this because I'm going to tell you it's not going to work. Do you get that after I set it equal to 0, the thing wouldn't factor? Because that's not a minus. Otherwise, it would have factored. Okay? But since this thing's not going to factor that way, then setting it, like setting it equal to 0 and trying to factor it is fruitless. So, what do? You can square root them, but not yet. First, we have to get this x squared alone. So what do I do first? Divide by 9. Divide by 9, divide by 9. And I have x squared equals negative 4/9. Next step, square root, and it involves 2 weird things. The square root of a variable, which is not x. Some kids don't know that yet. in my class, I think everybody knows this is absolute value x. But there's a lot of kids who are just being told to put x right there. That is not x. We graphed it, remember? I had you graph y equals square root of x squared. Do you remember that it looked like that? It's an absolute value. It is. It's the absolute value of x. And that's why we're going to end up at the end of the problem having a positive and a negative answer. All right, next I'm square rooting over here, and that's the other weird thing. Square root of a negative again. So it's I, and it's the square root of a fraction. Do you know that you can then square root at the top and square root at the bottom? You can. Happens to be works out really nice. Square root of 4 is 2. Square root of 9 is 3. So I get 2/3. Am I done? I'm really close. Then the absolute value thing breaks it into two parts. Now, I know you don't have to do that. You could just put a plus and minus on it at this point. But in a moment, when we do this problem right here, let me show you. You're going to subtract 1. Then when you square root, you have the absolute value of, and that's going to force you to do two equations. One with regular I and one with negative I. Let's stop for a minute and get a blank page going here and say, do you know how to solve this? That's another skill right off the ACT. I expect you to be able to solve absolute values. Split it. Figure out the two answers. One of them comes out to 42. One of them comes out to negative 42. It's really, really critical because what's underneath here can either be a 42, and obviously that would work, or a negative 42 also works. That's why we have to make two separate equations for it. Did you get? Add 3, 45. Raise your hand if you had 45. Good. Did you get? Plus 3, negative 40, no, negative, what is it? 39, is it? Yeah, I think it's negative 39. Who had negative 39 before I wrote it? Okay, good. So absolute values are another topic that you have to know. All right, let me back over to my PDF here. Oh, make sure I pull up the right one. I think it's a little further than we were. I'll scroll it back up. So, where did we leave off? In that zone, I think. Let's go down here. Yep, gotcha. I'm not going to assign any more of these except, you know what? I do want to assign that one because I want you to be reminded that if you can factor it, you should. And that one will factor, and the answers are a lot faster that way. You don't have to deal with the absolute values and all that stuff. You just factor that one. D will work out nice. Okay, so do D. Next, let's get down to this kind where we have the I's. The I's have it. This one will be super easy. I'm just going to multiply it out. I times 3i is 3i squared plus 4i. And I'd cry a little bit and mark it wrong because you're on the right track, but yes? Exactly. So let's this really then. Negative 3. So I could say negative 3 plus 4i. In fact, that's better than having the negative 3 at the end. Do you remember how the imaginary part's supposed to go second? All right. Lots of little reminders in a review day like this. Here, some kids are just going to go 4 squared and I squared. You can't do that. To really square something, you have to times it by itself. And then at the end, you times everything by 5. How come this is going first? I like to think of it as it was a power, and powers go before multiplication. Right? Please excuse my dear Aunt Sally. Okay, so that's why I would do the FOIL part first. All right, so you do an A and B, and honestly, these are really easy, except what if they throw a negative in it instead, and you're like, what does that mean? This means it's a subtract problem. So do E also. E is an elephant. All right. Moving on. Hey, that's the end. Sweet, we're at the end of that worksheet. Okay, now there's one more worksheet. I'll circle some on there, and you're going to get some work time. All right, I'll pause for a second while I pull up the second worksheet. The second worksheet looks like this. It's called Quadratics Review Part A, and this is the Quadratics A was definitely the easy part of quadratics. So this day overall is a pretty easy day of review. There's a lot of topics, and they're really important. Do you remember vertex form? I'm going to give you an example of vertex form. 3 times x minus 4 squared plus 5. Obviously, vertex form must be about the vertex, right? Do you remember what the vertex is then for this guy? 4 comma 5. I heard somebody say it. You are right. Why did they change that first one from negative 4? It's on the inside. Can't trust stuff on the inside, right? Okay, so 4 comma 5 would be our vertex. If there was, you remember how I said yesterday there was a big factoring theme on this final? There's another thing that came up a ton in this class, and it was the vertex. Why is the vertex so important on graphs? Well, because vertex form is one of the big 3 forms, okay? And also because as soon as you know the vertex, let's say I know the vertex is right there is at 8 comma 2 or something, then I know the domain and range because of that. I also know the axis of symmetry because of that. I also know if this is a word problem and it's about like a submarine going underwater, I know where its lowest point was, or if it's a ball in the air, its highest point. The vertex is a really big deal. So we have a whole bunch of ways to find it. One is to put things in vertex form. Another is a formula for vertex that I'm going to guess only half the class hasn't memorized. There's a formula for vertex. If you know it, write it on your iPad right now. If you just got to that question on the final, this is what it would feel like. What's the formula for finding a vertex? I'm not talking about if they give you vertex form. That's too easy. You just got an equation like this, and you're trying to figure out the vertex of it. There's a formula for that. There's an app for that. We didn't use it that often. That's why it's hard for you to remember. I'll give you this hint. It's part of the quadratic formula. Don't say it. Write it down. Okay, so here's the quadratic formula. Hold on a sec. There we go. X equals negative b plus or minus square root. Changing colors. B squared minus 4ac all over 2a. Now, I did that because b squared minus 4ac is important, but it's not the right formula, if that's what you thought it was. Nope, that doesn't give you the vertex. Who knows what gives you the vertex? Yes. Negative b over 2a is correct. It's this part right here. That part gives you the vertex. So back to that problem I had a second ago. Can somebody read it to me because I can't see it anymore? The one that started with like 3x squared, blah, blah, blah. It was minus 7, I think. Hold on. I'll go back. Was it? You know what? It doesn't matter. I'm going to make a new one up. How about that? 8x squared minus 3x plus or minus 7 or something like that. Doesn't matter. I don't know what the a was, but okay. So if I asked you to find the vertex of that green formula right there, you could use negative b over 2a and find its vertex. Negative b would be positive 3 over 2a. What's 2a? X is 3/16. That's the x of the vertex. Somebody said that was the axis of symmetry. Apparently, they've even forgotten that they said that. Yes, it's also the axis of symmetry. The axis of symmetry, that line, the dotted line that runs down the middle of a parabola. So if I have my parabola drawn here, I missed kind of where the vertex was, but I'm kind of close. Anyway, that line that runs right down the middle, that would be at x equals 3/16. How would I find the y value of this point? The x value is 3/16. You'd have to stick 3/16 back into the equation. All right. Okay, so there's a big review of a lot of stuff. What was that key formula? The vertex formula is what? Negative b over 2a. All right, I'd like you to practice that by just, here's the problem. I'll make it really simple. Nope. Yeah, that works. I'd like you to find for me what the axis of symmetry is and the vertex. You might be like, you didn't tell me a formula for the axis of symmetry. Yeah, because I gave you the formula for the vertex. I did. You're not writing. Right. Just move the hand. It'll keep you awake, too. Start by writing the formula. What is it? Negative b over 2a. In this case, what? 5 over 2. Okay. So 5 over 2, also known as 2.5, is the axis of symmetry. And then the vertex has to be 5 over 2 comma something. And then you'd go put 5 over 2 in this formula. That's kind of nasty. I didn't mean for it to be that nasty, but that's what you'd have to do. I thought I was making one that was going to come out to a whole number. I screwed up. It's not an illegal question, but it was way harder than I intended. All right. So you got that axis of symmetry formula down? Now, let's get back to our worksheet then. So here's our vertex form. What's general form look like? They look like the normal ones, like 3x squared plus 6x minus 9. They're all multiplied out. To get general form, generally you just multiply one of the other ones out. And then the last kind of form, by the way, in case you're not feeling very motivated right now, I'm doing problem 1 of the homework with you. I'm helping you. You should be doing this with me. The factored form is, again, these are different equations right now. Once you get it all factored out, let's say it looked like that. That is not the correct factoring of this or anything. These are different equations. But factored form kind of looks like that. So what do we put over here in equation slash formula? There's a general rule for this. Ax minus, does anybody know what those next two letters are? X minus h plus k. It's kind of like y equals mx plus b. They pounded that into your head pretty well. You remember that one, don't you? All right, it's kind of like that. That's for slope intercept form. This is for vertex form. How about general form? Using letters. Yes? Yep. That's why we're doing it right now. Ax squared. What's the next one? You should know what letter comes next. Bx plus c. That's general form. Now the only one you won't need to know letters for is factored form, because you could put anything in there. Get what I mean? Those aren't unique. Here's an example of one. 3 and 7. If I wanted to use letters, I could say R and Q, or I don't care what letters you use for that. Do get used to H and K, because it comes back in pre-calc. I know that's where you're headed. So that one in that H and K one is worth memorizing, that they're H and K. But this one, for factored form, I don't really care what letters you use. Okay, and what are they good for? I'm not going to answer this part. I'm going to give you a word bank. One of these forms is good for tells you the vertex I bet it's going to be hard to figure out what that one is. One of these forms is good for telling you the roots, the zeros. One of these forms can be solved like almost instantly. I can look at it and go, oh, the zeros are this and this, the roots, the answers. One of these is good for telling you A, B, and C. Why would you ever care about that? Because then you must be doing the quadratic formula. If you need the quadratic formula, A, B, and C, one of these forms is really slick. And the last little thing is one of these forms, if you look at these three example problems, one of them tells you the y-intercept. It's just sitting there. But only one of the three forms has the y-intercept just sitting there. To help us out, which form is it that has the y-intercept just sitting? General. Very good. That's right there. Okay. Now I want you also to do number 2. I know it seems like a lot, but there's no, there's only one number 1, and I can't like cut it down because you need to know those things. Number 2 has got all the key spots: the vertex, the axis symmetry, the x-intercept, the y-intercept, writing the equation in vertex form, writing the equation in factor form, writing the equation in general form. And I'll tell you this, there's only one of these that even I can't do without doing something else first. I can't do general form of this unless I get another form of it first. I can't look at that and say, oh, this one's got to be 3x squared plus 5x plus 2. I can't do that in my head. Even I can't do that. So how are you supposed to get general form? You get one of the other forms and then do what? Multiply it out. Multiply it all the way out. So which form is easiest? I think it's the form that depends on this, because that's the vertex. Now, some of you guys are going to like the other one better, but this one's pretty easy. If I know this is at 2, -1, then the vertex form, I know vertex form always looks like this, and then there's a vertex that's here and here. See why it's pretty easy? If once I know the vertex, I just slap it in there. And then I can take that form and multiply it all the way out, and I can get general form. So I'd do this first. I'd multiply it out to get this second, and then take a wild guess what I'm going to suggest you do with your equation once it's in general form, so you can solve this one. You factor it. You factor it to get factored form. All right, so the suspense is killing me. What is vertex form? Here's the vertex. What's the vertex form? X minus 2, good. Keep going. Minus 1. Okay, now if I multiply that all the way out, I get general form. I'm not saying this is the right answer. But let's say it was x squared minus 4x minus 12. Something about that is wrong for sure. Okay, but if then I factored this, I could put it into the factored form slot. See what I mean? All right. I'll erase the part that was clearly wrong. Okay, there's an extra practice on this number 3. You don't have to do it, but maybe you should if you're not good at this. If these come really difficult for you, then you should. You're trying to prepare yourself for this test. Sometimes I think people forget that it's not me trying to assign you this stuff to like, oh yeah, I have to do the thing you said to do. It's me trying to help you see what would help to study. All right. So moving on to, oh, this one is the same idea as this one. It's just in a different form. It starts as vertex form right off the bat. So if I was going to graph this thing, I would for sure start with its vertex. And then after that, I'd probably say, oh, it's been stretched and it's been from the original parent parabola, it's clearly moved 1 to the left. So it looks, anyway, I'd start with the vertex. It's been moved down. Say it's down here somewhere. And then don't forget that this has got a stretch factor of 3, so you can't do your normal width parabola here. It's 3 times as tall as normal. So you go over 1 and up 3. It's a very narrow, steep parabola. What's your best friend in graphing? XY chart. Good. Do you get that if you went completely brain dead about how to graph this thing, you could always just pick some points, connect the dots? Really, that's all it turns into. You graph like 6 dots, and go, oh, it looks kind of like a parabola. Okay, and you connect the dots. So XY chart, don't forget that that's really powerful for graphing. All right, moving on. We're in this little zone here. Write the equation in factored form. So basically they're saying factor it. And we really like to put in GCFs. Do you get that in this one and this one and this one, they all have something to factor out first. Before you even start, you got to notice, oh, it's got a 2 in it. Oh, it's got a 3 in it. Sometimes it's got an X in it. We like to have something that factors out of everything. This is the only one that doesn't have something to factor out of everything. That means it's going to be a little bit of a pain, but you will start with a 3x and an x. On this problem, I'd like you to do B, C, and D. Factoring is huge. We need to practice it. Yes? Yes. 4 was a graph problem. How about, you know what? Okay, I'll make 4 optional. I'll make 4 optional. Do it if you want. But definitely do 5. Graphing or factoring is huge. Number 6, write equation in general form. That means generally just multiply the thing out. We've done this on the top 20 a bajillion times. So hopefully you've got it. So I'm not even going to assign it. I want you to start, just do B. B is in banana. This one is saying stuff in words, and then you got to write an equation. It's the only one like it on the whole page. I think you should do that one. And my hint on those is always make a sketch. If I gave you a picture for this, it would be so much easier. So make a picture for yourself. I know where 2 comma negative 3 is, and make yourself a little picture of it. I'm not saying this is the right picture, but once you have a little sketch of it, it's going to be a lot easier to answer the question. That's also good advice for the ACT. If there's no picture, make a picture. Or sometimes you can't make a picture, so maybe it's make a chart or a table or a sketch of the situation even sometimes helps. All right, and then the very last one there, number 8. That should be a easy peasy f of negative 3. The only thing that's weird is like, wait a minute, but you always said to just follow that up to the graph. Well, then I guess maybe you should figure out where the graph's going to be when you get there. How could you do that? You could use logic of how far over and how far up it's going and stuff. Really what this is forcing you to do is to write an equation for this guy, and then you can stick in the negative 3. So can you write an equation for this parabola is what that last question becomes. Okay, I know that's a lot of teaching, and it's easy to get like burned out, zoned out. So this is the part where I'm done teaching you the new stuff for today. You got some problems that you should do to practice. If your final's going to go well, it's going to really depend on what you do tonight. And I know, but it's important to, like, I know this is a lot. You got a lot of finals to study for. But honestly, this is where I should probably remind you. You have 1 week. In 1 week and 1 day from now, you'll be done with finals. And some of you are going to drop your GPA in the next week. Many of you are freshmen or sophomores. GPA is very important. Work hard this 1 week, and then it will pay off for a long time. You can make a big difference during this week. You really can. So try to keep yourself motivated, keep moving, keep trying hard. Some of you guys have that A-, and you're going to bomb the final, and you're going to drop to a B+. And that's going to affect your GPA. B+s are not a GPA booster for most of you. Okay? So try hard. If you try hard, it will make a difference, especially in this week. All right. That's all I got for you for today.